Hi students, in this video we're going to use the addition rule to calculate the probability of two events, A and B, of either of those events happening. So after watching this video, you should be able to recall the addition rule for calculating probability of the union of two events, so either event A or B occurring. You should be able to use the addition rule to calculate probability and also recognize the link between mutually exclusive events and that addition rule for calculating probability when there are unions involved. Alright, so some things to recall, how to calculate probability. Okay, so using our rules that we've been looking at previously. Things we also have to remember would be some of our symbols used in set notation. So for example, using S or psi for our sample space, and then our symbols for intersection. Intersection means it's in both of our events. Our union, which means it's in either or of our events, and then also how to use Venn diagrams. We're going to use that to help us generate our addition rule for probability. So how we overcome that is by using the addition rule of probability and saying that the probability of either event A or B occurring, that is, our probability of A union B, is equal to our probability of A, which is in this circle here, plus our probability of B, which is in this circle here, and then we subtract our intersection in this last one. And the whole idea behind that is, once again, we've counted this intersection here twice. So what we've got to do in order to make sure we only count it once is subtract whatever our probability is here, or whatever value is here in our intersection, to make sure it's only counted once. Now, in the event that you've got some mutually exclusive events, then there's no intersection between those two values. That is, the intersection of our events A and B is just 0. So in this case, for mutually exclusive events, the probability of either event A or B occurring is just adding our probabilities because there's no intersection in between them. It's when we do have intersections, we do need to subtract that intersection value or that intersection probability when we're calculating the probability of a union. All right, so let's do this in an example. We've got the first 25 integers that we're considering here, and we're randomly selecting numbers. Let the event T be the number is divisible by 3, and F are the numbers that are divisible by 4. So let's list out all our outcomes for T and F. So going up to 25, our numbers that are divisible by 3 are 3, 6, 9, 12, 15, 18, 21, and 24. For F, our numbers that are divisible by 4, we'll have 4, 8, 12, 16, 20, and 24. All up to 25. Now, we're randomly selecting a number. So let's find the probability that our number is divisible by 3, or in our set here. Looking at T, we've got 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 numbers that are divisible by 3. So our probability of getting a number that's divisible by 3, selecting randomly from the first 25 integers, is just going to be 8. 8 in this set out of the possible 25 numbers we had to choose from. For 4, we've got 1, 2, 3, 4, 5, 6 numbers out of 25 again. Now, looking at our intersection, let's find some numbers that are in both our sets here. Well, we've got 12, 12, and 24 and 24. Those numbers are in both. So there's only 2 elements that are in our intersection between numbers that are divisible by 3 and numbers that are divisible by 4. So we can say the probability of picking a number that is divisible by 3 and divisible by 4 is 2 out of 25. So using the addition rule, let's calculate the probability that we randomly select a number that's divisible by 3 or divisible by 4. So our probability of T or F, our number is divisible by 3 or divisible by 4. So our probability it's divisible by 3 plus our probability it's divisible by 4, subtract our intersection, the probability of being divisible by 3 and 4, to make sure we don't count that value twice. So that'll be 8 over 25 plus 6 over 25, subtract 2 out of 25. 8 plus 6 is 14, subtract 2 is 12 out of 25 is our probability of selecting a number that's divisible by 3 or divisible by 4. Alright, so let's say we've got two events A and B, and the probability of event A happening is 0.6, the probability of event B happening is 0.7, and the probability of either of those events happening, or our union, is 0.85. We have to calculate the probability of A and B happening at the same time. So to do that, we can just use the probability, our addition formula for our probability. So probability of A or B happening is equal to the probability of A plus the probability of B happening, subtract the probability of A and B happening. Again, we're subtracting to take away, to make sure we don't count that intersection twice in each of those probabilities, each of A and B. Now we've got a number of those values, we can substitute them straight in. So 0.85 equals the probability of A, which is 0.6, plus the probability of B, which is 0.7, subtract the probability of A and B. Continuing to rearrange that, 0.85 equals 1.3, subtract probability of A and B. Now rearranging that, I'm going to add the probability of A and B to both sides and subtract the 0.85 from both sides. So the probability of A and B will actually equal 1.3 subtract 0.85, which equals 0.45. So the probability of both A and B happening is 0.45. Alright, now the probability of not A happening or B happening. Well, funnily enough, this one here is actually just going to be the complement of our union. So if the probability of A or B happening is 0.85, then the probability of A not happening and B not happening will just be the complement of what we've got up here. So the probability of 100%, will take away the probability where one of those things happens, so there's a 0.15 or a 15% chance that neither A nor B happens, because we know it's 85% chance that one of them happens, or at least one of them happens. So whatever's left over, 15%, that's our probability that neither will happen. Right, so after watching this video, you should be able to recall and apply the addition rule for calculating probabilities of unions of two events. Apply that rule to help calculate probability, and then define mutually exclusive events.